Hello everyone. In this video I am going to teach you how to insert a node into a doubly linked list, which is also a circular linked list. See, now I'll teach you first how to insert at the beginning of this linked list. Now see, this linked list is not empty. First let's see the case when the linked list is empty. See, we have two pointers, head and tail. So we will consider first the case when the linked list is empty. This is head pointer and this is tail pointer. Now see, head and tail will is a pointer which is used to point towards the first node and last node. Now there is no node present here, so head and tail will be 0. Now see, now I should insert a new node into the empty linked list and at the beginning of the linked list. That means if I insert means only one node will be present. So see here how to insert. First I should create a new node. For creating this new node you should use malloc function. So see here, I am creating, and for let's say the address of this node is 10. Now for accessing this node I need a pointer, so I am creating a pointer called new node. And let's say now I should store the address of this node, that is 10, in this pointer. So this pointer points towards this node. So what is the first step? I have created this new node by using malloc function. So I am writing as see here, new node equals to struct node star malloc size of node. Now I have created this new node by using malloc function, and size of node is 4 into 3, 12 bytes, because each take integer values. So 4 plus 4 plus 4, 12 bytes. Now see, now now you should ask the user what data he wants to store. So I am asking print f enter data. Suppose the user says 7 means 7 I should store in the data part. Data part of which node? New node data. So I am reading it here by using scanf function. Scanf %d comma and new node data. Now that the user enters the data 7. 7 is read as %d, that is new node data. New node is 10. 10's data is here. Here 7 I will put. Now see, now this is a empty linked list. How to say whether it's a empty or not? If head and tail is 0, you can say it's empty. So I am writing the conditions here. If head equals to tail equals to 0, then it is empty. So what you should do? In this case, how to insert this node into this linked list? So you should this head pointer should point towards this node, and tail also should point towards this node, because the first node and last node are same, that is this node only, because only one node is present. So head and tail should point towards this. So address of this node is 10. So 10 should be stored in head and tail. So I am writing here, see, head equals to tail equals to new node. Now new node address is 10. 10 is stored in head and tail. So this is 10, this is 10. So now tail is pointing to the node which is having address 10, and head is also pointing to the node which is having address 10. Now see, now you have just created a doubly linked list. You should make it a circular. Now you have created a doubly linked list with one node. You should make it circular. How you can make? See here. Now this is the previous pointer of this node. In this previous pointer I should store the previous node address. Now this is the first node. So previous node of this first node is what? Last node. But first node and last node are same, because only one node is present. So last node address is 10. So that I should store in this previous pointer. So how can I get 10? You can get it from new node address. So I am writing a C. Head previous equals to new node. Now see, head is 10. 10's previous is this pointer. In this pointer I am storing new node address, that is 10. So I am writing a 10. So it creates a circular link. It's pointing towards the same node which is having address 10. Now see, this is next pointer. In this next pointer I should store the address of next node. This is the last node. So the next node of this is first node. So this is also a first node. So address of first node and last node is 10. So I should store 10 over here. So how I can store? See here. Tail next equals to new node. Now see, tail is 10. 10 next is this pointer. In this pointer I am storing the address of new node, that is 10. So it creates a forward link which is pointing to the node which is having address 10. That is the first node. Now see, this is how you should create a doubly circular linked list when the linked list is empty. Now you have created with one node. Now see, now let's see the case when the linked list is not empty. See, this is the case now. You have two nodes present here. Now how to insert at the beginning? See, first step is I should create a new node by using malloc function. So see here, I am creating a new node. Now for accessing this node, let's say the address of this node is 10. For accessing this node I need a pointer. So I am taking a pointer called new node and storing the address of this node in here, 10. So this pointer points towards this node. Now I am asking the user to enter data. Suppose the user says 7, means it puts into this data part by using scanf function. New node data. New node is 10. 10 data, it's put 7. Now see. Now this pointer, this next pointer. In this next pointer I should store the next node address. If I insert this at the beginning, this will be the first node and this will be the second node. So I should store this node address, that is 100. I should store here. So how can I get, where can I get this 100 from? 100 is stored in head pointer. So see here, I am writing else. This is the condition when the linked list is not empty. Now see, new node next equals to head. Now see, what is new node next? New node is 10. 10 next is this pointer. In that pointer I am storing the address of head, that is 100. So this pointer is pointing to the node which is having address 100. Now see, now next step is this pointer. This is the previous pointer of this node. In this previous pointer I should store the address of previous node. So if I insert this at beginning, this will be the previous node. So address of this node is 10. 10 I should store here. So where can I get this 10 from? I can get it from new node address. And how to access this previous pointer? By using head previous. So see here, I am writing head previous equals to new node. Now see, head is 100. 100 previous is this pointer. In this pointer I am updating the address to new node address. New node address is 10. So I am updating here 10. So this pointer is not pointing to 200 anymore. This link is cancelling. See, this link is getting cancelled. And now this pointer is pointing to the node which is having address 10, that is this node. So it's in backward direction. Now see, you have created two links in forward and backward. Now see, now you have just created a doubly linked list. You should make it circular. How to make? See, this is the previous pointer of this new node. Now in this previous pointer I should store the address of previous node. But see, now this will be the first node. So previous node will be the last node when you make it circular. So last node address is 200. I should store 200 here. So how to get 200? You can get it from tail. So how to access this pointer? New node previous. So see here, I am writing new node previous equals to tail. Now see, new node previous is 10's previous. In this pointer I am storing the address of tail, that is 200. So this pointer is pointing to the node which is having address 200. So like this, I have created one circular link. Now I should create another circular link. See, now this is the last node. In the next pointer of last node, that is this pointer. In this pointer I should store the address of next node. Now this is circular. So the next node of this last node is first node. So I should store this address, that is 10 in this pointer. So where can I get 10 from? From the new node address. And so I am writing a C. See, I am writing here tail next equals to new node. Now tail next is what? Tail is 200. 200 next is this pointer. In this pointer I am storing the address of new node, that is 10. So I am writing here 10. Now this link is cancelling. It's not pointing to the node 100 anymore. It's not pointing. Now this node is pointing to the node which is having address 10. So this node. So see, you have created a doubly circular linked list. But see, you should make one more change. Head pointer is used to point towards the first node, but now it's pointing to the second node. How you can point to this node? So the address of this node is 10. So you should store in head 10. So you can access this 10 from new node address. So see here, head equals to new node. Now new node is 10. 10 I am putting in head. So head is not pointing to second node anymore. It's pointing to the first node. See, now you have inserted a new node at the beginning of a doubly linked list, circular doubly linked list. This is how you should insert. Now see, now I'll teach you how to insert a new node at the end of a doubly circular linked list. See, first let's see the case when the linked list is empty. This is tail pointer and this is head pointer. Head and tail will be 0 because it cannot point to any node because no nodes are present. Now see, now what is the step? You are creating a new node. Same step. Now you are putting data in it. Let's say 8. The address of this node is, let's say, 10. So I need a pointer for accessing this node. So I'm creating a pointer new node and I'm storing the address of this node, that is 10 here. So this pointer is pointing to this node. Now see. Now next step is when the head and tail is 0. That means no node is present. I'm writing head equals to tail equals to new node. So new node address is 10. 10 is put on head and tail. So this pointer is pointing towards this node. So now first and last node are same, this node. Now see, head previous equals to new node. Head is 10. 10 previous is this pointer. In this pointer I am storing the address of new node, that is 10. So it creates a circular link which is pointing to the last node, that is this node itself. Now see, head tail next equals to new node. Tail is 10. 10 next is this pointer. In this pointer I am storing the address of new node, that is 10. So this pointer is pointing to the next node which is address 10. So it creates a circular link. Now this is how you should create when the linked list is empty. Now see. Now let's see the case when the linked list is not empty. Now I am creating at the end. So using malloc function I am creating. Now for accessing this node I am taking a pointer called new node. This address is 300, let's say. So 300 is stored here. So this pointer is pointing to this node. Now see, now I am asking the user to enter data. Let's say 8 is stored. Now see, now now I am inserting this at the end of a linked list. So this should be the last node. How to fix this as the last node? See, now this is the previous pointer of this node. Now in this previous pointer I should store the address of previous node. If you insert this last, then this will be the previous node. So previous node address is 200. 200 I should store here. Where can you get 200 from? 200 is stored in tail. And for accessing this previous pointer, you can access through new node previous. So see here I am writing else this part. New node previous equals to tail. Now what is tail? Tail is 200. I am putting 200 in new node previous. New node is 300. 300 previous here. Here I am putting 200. So this pointer is pointing to the node which is having address 200. Now see, same this pointer also I should change. The next pointer of this node, that is here. Here I should store the address of next node. Now this will be the next node. So 300 I should put here. So where can you get 300 from? It is stored in new node address. Now how to access this pointer? You can access by tail next. So see here, tail next equals to new node. Tail next is 200 next this pointer. In this pointer I am putting the address of new node, that is 300. So it's 300 is written here. Now see, now this link will get cancelled. It's not pointing to 10 anymore. This pointer is not pointing to address 10. Now this pointer is pointing to the node which is having address 300. So it's in forward direction like this. Now see, now you have created a two links in backward and forward. Now you should make it a circular. How to make? See here. Now in this pointer, in the next pointer of this node, last node, you should write the address of next node. In the next pointer you should write the address of next node. what this is circular. So the next node of last node is first node. So address of first node is 10. You can get it from head pointer. Now 10 you should store here. So see here I am writing new node next equals to head. Head pointer is 10. 10 I am storing in new node next. New node is 300. 300 next is here. Here I am storing 10. So this pointer is pointing to the node which is having address 10. So this node. Now see. Now I should change this pointer. Previous pointer of first node. In this previous pointer of first node I should store the address of previous node. Since this is a circular, previous node of first node is last node. So address of last node is 300. 300 I should store here. So I can get 300 from new node address. Now see, I can access this pointer by using head previous. Now see, I am writing head previous equals to new node. Now new node address is 300. 300 is put in head previous. Head is 10. 10 previous is this. In this I am putting 300. So this link is getting cancelled. This link is not pointing to 300 this 200 address anymore. This node it's not pointing to this node anymore. Now it's pointing to address 300. So it creates a link, circular link like this. So see, this is how you should create a insert a node at the end of a doubly linked list, but it's not complete. See here, tail is a pointer which is used to point towards the last node, but it's pointing to the second last node. So how I can point it to 300? So where can I get that 300 from? You can get it from new node address. So see here, tail equals to new node. Now new node is 300. 300 is put on tail. So this pointer is pointing to node which is having address 300. So see, I have inserted this node at the end of a doubly circular linked list. This is how you should insert. Now I'll teach you how to insert a new node after a given position. Now see, you want to ask the user after which position you want to insert a new node. So I'm writing this statement. See here, printf enter position. Now if the user enters that position value, means that value should be stored in position. So that value should be read as position. How can I read it? By using scanf function. So I'm writing scanf %d comma and position. Now the value is stored in position. Now see, suppose there is 4 nodes present here. There are 4 nodes in this linked list. Now if you are asking the user to enter position, so if the user says 5 means what? You want to insert a new node after 5th position. That means in 6th position you want to insert. If you want to insert at 6th position, you want to know the address of 5th node. There should be 5th node present there. But there is no 5th node here. Only 4th node is there. So it's not possible. So you should print invalid. So what is the condition? I want to write the condition. If, now see, this position you have entered is greater than number of nodes present here. So 5 is greater than 4. So you can say it's invalid. Position greater than count. Count is tells us number of nodes present in the linked list. Now if this is greater than count, now you should print invalid. So printf invalid. So this case is invalid. Now how to count number of nodes present in the linked list is separate program. You can see in my another video. Now see. Now now this is invalid. So it again asks the user to enter the correct position. Suppose if the user enters 2 means C, you should insert the node after second position. So this is first node, this is second node. So this is third node. In between of these two I should insert a new node. How to insert? See, first thing is I should create a new node by using malloc function, and for accessing this node I need a pointer. So I am creating a pointer called new node. Let's say the address of this node is 150. So 150 is stored in this pointer. So this pointer is pointing to this node. Now see, now next condition is I should ask the user to enter data. Suppose the user says 7 means 7 gets inserted over here. Now see, now this is the how to fix this node in between of this two. See that this is the previous pointer of new node. In this previous pointer, I should store the address of previous node. Now if you put this node in between, previous node of this will be this thing, address 100. So I should put this address 100 into this pointer. So where can I get this address 100 from? I need a pointer pointing towards this node, but there is no pointer pointing to this node. So I should create a separate pointer called temp. So see, I'm creating a pointer temp. Now this temp pointer should point towards this node, but you can't directly point to this node. In linked list you can't directly point. So in linked list the temp, I'm creating a temp pointer and I'm pointing it to the first node. Then one by one I should move the temp pointer till temp pointer is pointing to this node. So see here, first the temp pointer is pointing to this node. So I'm writing the condition, see here, else temp equals to head. Now head address is 10. So 10 is stored in the temp. So temp is pointing to the first node. Now see, now next step is while I less than position. What is this condition? See, what is I? I is used to tell the node at which I is used to tell that which location is the temp pointer pointing to. At which node the temp pointer is pointing. At starting, temp is pointing to first position. So I should define int I equals to 1 at starting. So this is I pointer. I is storing 1. Now see, now at starting this temp pointer is pointing to 1. Why I am writing this condition? See, you should move this temp pointer in forward direction till temp is pointing to this node. After this node I should not move the temp. That's why I am writing this condition, terminating condition. Now see, now in this case, now I am checking whether I is less than position. I is 1, 1 is less than 2. So you should move the temp pointer one step forward. Now temp should point towards 100. How I can access 100? From the next pointer of this node. So I am writing a C. Temp equals to temp next. Now temp is 10. 10 next is 100. In this, this 100 is put on temp. So now temp is 100. Now this pointer is cancelling and this temp pointer is pointing to next node, that is address 100. Now see, this temp pointer is pointing to second node. So I should be 2. So I should increase I value by 1. So see here I am writing I plus plus. So 1 is updated to 2. Now again go back and check the same condition, whether I is less than position. I is 2 now. Position also 2. So this is not less than position. So I am not entering into this step. So that is temp equals to temp next is not done. That means it's temp pointer is not moving one step forward. So you are stopping temp pointer here. That's why I am writing this condition while. Now see, temp pointer is pointing to this node address 100. Now what to do? See, now this is the previous pointer of new node. In this previous pointer I should store the address of previous node. If you put in between of this two node, then this previous node will be this node. So address of this node is 100. 100 you can get it from temp. So 100 I should store here. So I am writing SC. New node previous equals to temp. Now new node previous is 150 previous. This pointer I am storing temp address, that is 100. So this is 100 now. Now this pointer is pointing to a node which is having address 100, this node. So it's pointing like this. Now see, now this is the next pointer of new node. In this pointer I should store the address of next node. Now if you put in between of these two nodes means the next node will be this node. So address is 200. That 200 I should store here. So how can I get 200? Where can I get this 200 from? 200 is stored in the next pointer of this node. Now this node address is stored in temp. So I can get this pointer from temp next. So see here, now I am writing this new node next equals to temp next. Now new node next is what? New node is 150. 150 next is this pointer. In that pointer I am storing the address of temp next. Temp is 100. 100 next is 200. 200 I am putting here. So this pointer is pointing to the node which is having address 200, this node. Now see, you have just created a single link. You should create a double link. So see, this is the previous pointer of this node. In this previous pointer, I should store the address of previous node. Now this will be the previous node. So 150 I should store here. Where can I get 150 from? This new node it's stored. Now see how to access this pointer. You can access this pointer from new node next previous. This for accessing this pointer you should know the address of this node. Now this address of this node is stored in the next pointer of new node. So see here I am writing. Now new node next previous equals to new node. Now see new node next is what? New node is 150. 150 next is 200. Now 200 is previous. 200 is this node. 200 previous is 100. So now this is the pointer. In this pointer I should store the address of new node. New node is 100. No, sorry, new node is 150. So I'm storing here 150. So see, now this pointer is not pointing to this node anymore. This pointer is pointing to this node having address 150. Now see, you have created one double link. Now here you should create another double link. So this pointer, this next pointer of this node, you should point it to the next node. That means next node is this node. So this address 150 should be stored here. So I can get this 150 from new node address and I can access this pointer from temp next. So see here, temp next equals to new node. Now temp is 100. 100 next is this pointer. In this pointer I am updating the value to new node address. New node address is 150. So I am writing here 150. So this link is getting cancelled. And this pointer is pointing to the node which is having address 150. So see, you have inserted this node in between of second and third node. That means you have inserted after second position. This is how you should insert a new node after a given position. And that's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.